On July 1, 2025, astronomers watched in awe as 3I/Atlas, a massive interstellar object, shot into our solar system at over 60 kilometers per second, its orbit cutting straight through the asteroid belt. For just a moment, the possibility of a collision with Earth was real enough to spark a global alert. Only the third interstellar visitor ever detected, this object isn't bound by the Sun, and the consequences of a high-speed impact would be unthinkable. Is the threat truly as massive as the headlines claim? Or does the real story hold a scientific surprise that could change how we see our place in the cosmos? On the night of July 1, 2025, the Atlas telescope in Chile detected a faint, fast-moving object, apparent magnitude 18, cutting across star fields crowded with summer constellations. Within hours, observatories from 2 continents began tracking its path, feeding astrometric data to the minor planet center. The numbers told a story that was almost unbelievable. This was no ordinary comet. Its orbit was hyperbolic, meaning it wasn't bound to the Sun at all. Instead, it was a true interstellar traveler, moving at nearly 60 kilometers per second, about 130,000 miles per hour. That's more than twice as fast as the average solar system comet. The designation came quickly. 3I/Atlas, the third confirmed interstellar object after ʻOumuamua and Borisov. Early orbital solutions showed it would never loop back. It was a visitor, not a resident, here for a brief one-way pass through the inner solar system. The excitement among astronomers was immediate. Pre-discovery images from the Zwicky Transient Facility and other sky surveys stretched the observation arc back to mid-June, tightening the object's trajectory and shrinking uncertainty by more than 90%. Physical characteristics set 3I/Atlas apart from anything seen before. Hubble and Gemini telescopes confirmed a developing coma, a hazy cloud of gas and dust, surrounding a nucleus likely between 2 and 5 kilometers across. The coma itself grew rapidly, reaching over 26,000 kilometers in diameter by early July. Spectroscopy revealed an abundance of carbon dioxide, with traces of water vapor, carbon monoxide, and even atomic nickel. The coma's color index, a deep red invisible light turning neutral in the near-infrared, hinted at a dust composition more like trans-Neptunian objects than any typical comet. As solar heating increased, the coma brightened and began to stretch into a subtle tail. Not as flamboyant as some comets, but unmistakable in time-lapse images. The negative polarization measured by polarimeter at major observatories suggested a mix of icy and dark grains, unique among known comets. Even at a distance of hundreds of millions of kilometers, 3I/Atlas was already active, its chemistry and structure announcing its origin from beyond the Sun's reach. With every new observation, the scale of this event became clearer. Here was a fragment of another solar system, barreling through our own at breathtaking speed. Its path would take it across the main asteroid belt, through the orbits of Mars and Earth, and back into the deep. The story of 3I/Atlas was just beginning, and every telescope on Earth was watching. Right now, 3I/Atlas is threading its way through the main asteroid belt, gliding between worlds that have circled the Sun for billions of years. Its coordinates place it just past the orbit of Ceres, the largest object in the belt, on a path that will carry it inward toward Mars. The numbers are precise. Perihelion sums in late October 2025, when the comet will swing closest to the Sun at about 1.4 astronomical units, just inside the orbit of Mars. For Earth, the minimum distance will be 1.8 astronomical units, roughly 270 million kilometers, safe by any standard, but close enough for telescopes to catch every detail. This isn't a lonely journey. The sky in 2025 is unusually crowded, with at least 7 significant comets sharing the inner solar system. C/2025 R2, known as SWAN, will reach perihelion on September 12th and pass within 0.27 astronomical units of Earth in late October. Forecasts suggest SWAN could hit magnitude 4 to 6, making it visible to the naked eye from dark locations. Not far behind, C/2025 A6, or LEMON, is expected to peak at magnitude 3 or 4 around November 8, potentially outshining SWAN and drawing crowds of skywatchers to rural fields and backyard observatories. Spacecraft will have their own comet to chase. 414P/Stereo makes its closest solar approach on September 27th, best captured by solar observatories in orbit. These are just the highlights. Several other comets, Pan-STARRS, SOHO, and another Atlas, will add their own faint trails to the mix. For astronomers, it's a rare convergence. 7 icy visitors, 2 of them possibly bright enough to see without a telescope, all within the same observing season. Amateur networks are already buzzing. Global comet chaser groups are organizing coordinated campaigns, readying cameras and telescopes to catch every outburst, every change in brightness, every twist in a tail. Online forums fill with finder charts and magnitude predictions, while observatory teams post real-time images and data. It's a cosmic traffic jam. 3. I/Atlas is the out-of-town guest, barreling through a sky that hasn't been this busy in decades. With so many comets in play, every night brings a new chance for discovery, and every observer, professional or amateur, is part of the story. Panic headlines always follow a story like this. If an interstellar object is streaking through the inner solar system, surely someone must be worried about a collision. But the numbers tell a different story. When 3I/Atlas was first flagged, the Minor Planet Center and JPL Horizons teams kicked off their standard workflow: gather every observation, stack them, and see how the orbit holds up. The earliest calculations, based on only a handful of data points, left room for wild scenarios. But as more detections poured in, the uncertainty cone shrank by over 90%. Within days, the minimum approach to Earth settled at 1.8 astronomical units, about 270 million kilometers. That's not even close in planetary terms. The asteroid belt, too, is emptier than most people imagine. There are over 1 million cataloged asteroids larger than a kilometer, but they're scattered across a volume so vast that the odds of any single object, comet, spacecraft, or interstellar visitor, hitting one during a single crossing is about 1 in a billion. This isn't just theory. Spacecraft have been threading the belt for decades without incident. The same logic applies to 3I/Atlas. Even with its hyperbolic speed and unusual path, the collision probability with any known asteroid remains vanishingly small. This isn't the first time public anxiety has outpaced the data. In 2024, asteroid YR4 made headlines with a supposed impact risk, only to have its threat erased as soon as new observations came in. The lesson is clear. Every additional measurement tightens the orbit, collapses the uncertainty, and turns panic into precision. The real story is not about danger, but about the power of continuous observation and the calm that comes from letting the numbers speak. Solar maximum is ramping up, and that means the sun is about to put on a show, one that 3I/Atlas will play a starring role in. When the sun hurls a coronal mass ejection, or CME, toward the inner solar system, its charged particles can slam into a comet's tail, sometimes snapping it off in a single, dramatic event. These tail disconnections are rare, sudden, and spectacular, like watching a cosmic wind shear a streamer loose. With perihelion landing right in the heart of solar maximum, the odds are better than usual that 3I/Atlas will be caught in the blast zone. Spacecraft like SOHO and Stereo stand ready to capture the moment frame by frame, and ground-based observatories are lining up their schedules for the same window. If a tail snap happens, the data could reveal how interstellar dust and gas respond to solar storms. Information scientists can't get from theory alone. But the story doesn't end with solar fireworks. There's a bigger question at play, one that stretches across light years and epochs. Suzanne Falsner, a researcher at the Max Planck Institute, has argued that objects like 3I/Atlas may be more than cosmic tourists. Her simulations show that in young planetary systems, where gas and dust are thick, interstellar wanderers can be captured, acting as seeds for new worlds. These instant building blocks could explain why some planets form faster or carry chemical fingerprints from distant stars. The detection of 3I/Atlas after Oumuamua and Borisov is a kind of proof. These travelers are common enough to have shaped the history of countless solar systems, including our own. Behind the scenes, a global network keeps watch. The International Asteroid Warning Network, NASA's CNEOS, and observatories from every continent are pooling data in real time. Every new image, every tweak to the comet's path feeds into a pipeline that can spot changes as they happen. It's a planetary-scale laboratory working without pause, ready to catch the next surprise. For scientists, the real payoff isn't just ruling out risk. It's bearing witness as the universe runs an experiment we could never design ourselves. With 3I/Atlas, discovery is the main event, and the best views are yet to come. On July 1, 2025, astronomers at Atlas detected 3I/Atlas, only the third confirmed interstellar object ever observed, moving at 61 kilometers per second. Careful tracking by the Minor Planet Center and JPL Horizons has ruled out any risk to Earth, with closest approach set at 1.8 astronomical units in mid-December. Despite headlines, calculated impact odds are less than 1 in a billion, and asteroid belt collisions remain similarly remote. Scientists are focused on what 3I/Atlas can reveal about interstellar chemistry and how such objects might seed young planetary systems, referencing Suzanne Falsner's research and recent solar maximum data. Some questions remain, including the exact composition of 3I/Atlas and the long-term role of interstellar objects in planet formation. As agencies monitor its journey through a crowded 2025 sky, the evidence points to discovery, not danger. The passage of 3I/Atlas is a rare documented opportunity to witness an interstellar visitor in real time.